Hi friends, today I'm going to show how to draw a molecule in Gauss view. This is a Gauss view software. So you need to first click on this Gauss view software, double click on this software. It will take some time to open the Gauss view software. So here the double clicking the Gauss view is opened and new window also opened to create a molecule. So to create a molecule, first of all you need to go to file and new molecule group, enter a new molecule group, and here you can see that in the second row the C6 you can see here. If you click on this one you can able to see the periodic table. Suppose if you want to draw a molecule of CH4, that is methane. So if you will click on this carbon, here all kind of selected fragments will come. So from that you need to select what kind of molecule you want to draw. So here I want to draw methane. So for methane there are 4 hydrogen sigma bonds. So that's why we need to take this. We need to click on this one, and then you can see in the builder fragment, you can see here the methane structure, and you can bring the cursor here and you can click here, then you can get a methane structure. So after drawing this structure, so how to save this structure I will show now. So go to file and save option is here, enter and save. So wherever you want you can save it. So I am saving in D drive and E folder. I am saving, and we need to give the name as like methane. I am giving meth. Any name you can give. So after saving this methane structure, so we need to go to results and we need to view or edit file. Go to view or edit file. So from this view file you can see, you can able to see the first row is checkpoint file is generated, and in the second row, that is called root section, that is there is a method, that is attribute method, and this is called basis set. Whatever we want basis set, that basis set we need to give, and this geometry connectivity is not that much important, we need to remove that, and we need to write opt space frequency. So after that we need to give one space and we need to give the title card required. Whatever name you want to give, you can give as a title card. After that we need to give one more space, and we need to write the charge of the molecule. From the charge we can calculate the multiplicity by using 2s plus 1 formula. So here the charge is 0, that means the spin is 0, that means 2 into 0 plus 1, that is 2s plus 1 means spin is 0 means 0. Here spin is 0, that's why it is 2 into 0 plus 1, that means the multiplicity is 1. So after that you can see here the xyz Cartesian coordinates of methane molecule, and these are the atoms, and these are the xyz Cartesian coordinates. So after that we need to eliminate this numbering, delete this numbering, and we need to give the space. After that we need to save, enter on save, and this is asking the save the following file in this folder. So then press OK. Now the structure was saved. So after saving the structure, we need to run the structure in Gaussian. So for that I am opening Gaussian 09 software. Then you need to go to file and open the where the file location is there we need to go. So I have saved in D drive, E folder. So you can modify the date. Here it is myth3. I have saved as a myth. Then open here. After opening, so to run this job we need to click on this right side above run option. So after that it will ask where you want to save the structure, output structure. So I want to save in desktop, so I click on desktop. So then please enter on save. So that structure will save on desktop. So to finish this job it will take almost 1 or 2 minutes. Why? Because it is a small molecule, so that's why it won't take long time to finish. So there are only 5 atoms, that is including carbon there are only 5 atoms, so that's why it won't take much time to complete the job. I think in 1 or 2 minutes it will finish. So let's wait for 1 more minute. One minute completed. We need to wait for 1 more minute to complete the job. Yeah, now almost it's going to finish. Yeah, now frequency calculation is going on. Yeah, now the job is completed. So that we can know from the processing complete option, it will show in the run progress. So that from that we can confirm that the job is finished, or otherwise you can see at the end the job CPU time it will show, that is 0 days 0 hours 0 minutes, that 20 seconds. That means this our job is finished in 20 seconds. So after that we need to close this. Then we need to open the output file by using Gauss view. Open, go to desktop. We have saved the structure in desktop. See here myth.out, that output file is generated in desktop. So double click on this. Now you can able to see the structure of methane here. So after that we can see what is this 4 number. So you don't know, so that's why we can able to see these 4 numbers by clicking on this option. So these 4 numbers are, so to get the lowest energy structure, so to get lowest energy structure the molecule is vibrated, and finally it get decrease the energy, and finally we got the local minimum energy. Here actually this whatever energy we are generating here is local minimum energy, not global minimum energy. So here from the results you can able to see in summary, there is whatever we have method used, we can see that is Hartree-Fock method we used. Basis set we can see that is 32G1G basis set. Charge we have given 0 and spin is 1, that is singlet, and solvation, we did not give any used any solvent here, and this energy is generated in Hatry, that is minus 39.976878 Hatry, and Harian RMS gradient norm is 0 Hatry, and there are no imaginary frequencies, this should be 0. So for all the molecules, the imaginary frequencies should be 0, but for transition state molecules, the imaginary frequency should be 1. And here the dipole moment is 0 and polarizability is 11.452, and point group of this one is tetrahedron TT. So like that we can you can draw some other small molecules, and you can do you can do the Gaussian calculation in the same way. Thank you.